Okay, so I continue with the webinar. Remember that you will be mute all along the session, but there is a question box for you to write down your questions. Do not wait until the end. You can drop your questions as soon as you got it. Today's topic is about how to enhance the capabilities of PTC Codebeamer with the Systems Engineering Suite. You will see two tools collaborating together to make the most of them. So this is the agenda for today. I will start with a brief introduction of the reuse company and myself. Then I will describe briefly PTC Codebeamer, like the host tool, plus the Engineering Studio, which is the tool we have connected to this Codebeamer. And then I will speak about some scenarios that this integration make possible, especially by means of the application of artificial intelligence algorithms plus classic semantics. And then I will show four main scenarios, first with a couple of slides each, and then with live or video recorded demos about all of them. The intention is not to get into big detail in these four scenarios, because each one of them perhaps could be suitable for a 1 hour webinar dedicated to this particular topic. And most of them has been covered in previous webinars that you can refer in our website. So the idea is just to describe the integration and not the details of these different techniques. So, few words about the reuse company, established in 1999 as a spin-off of university here in Madrid, merging together systems engineers with software engineers to make possible the series of products that I will be presenting today. The company is still headquartered in Madrid, with offices in the USA, in Stockholm, and a special delegation in Tokyo. The main aspects of the tool, of the company is to be a solution provider with a special focus on the application of artificial intelligence and classical semantic technologies to improve the digitalization of the systems engineering lifecycle. If you know us for a long time ago, then of course we maintain our topics about requirements quality, and all these aspects. However, we have extended to cope with this digitalization of the management of the digital thread. Our main business is in these sectors like aerospace and defense, automotive, energy, healthcare, infrastructure, legal, and still a little bit about software companies. And this is myself, Jose Fuentes, and the Chief Sales Manager at the reuse company. I think most of you already know me pretty well. So I started as a product manager of the quality-oriented tools or requirements quality tools. I'm INCOSE certified, member of the Technical Leadership Institute, and part of the board nowadays of the Spanish chapter of INCOSE, a contributor to some working groups in INCOSE and many other things. So let's go right to the point. We have a lot of topics to discuss today. So first I will start introducing Codebeamer. Perhaps if you are interested in this webinar is because you are already a Codebeamer user, so nothing to say, just to say that Codebeamer is nowadays one of the most important tools in the field of the ALM, Application Lifecycle Manager. It includes a very modern and agile interface through or via web browser, providing requirements management, risk management, test management, and of course end-to-end traceability for all these aspects that has been managed, like risk or test or requirements. This is one of the topics that we will cover today: how to extend this end-to-end traceability when it comes to trace beyond the limits of Codebeamer. So that is why the other tool that you will see today is our tool, SES Engineering Studio, which is a modern tool leveraging some activities on top of other tools. So the idea is not you cannot see this tool as a replacement for, of course, it is not a replacement for Codebeamer, but it is not a replacement for any other of the tools that we connect to. Today, we connect to more than 50 different tools in the fields of requirements management, MBSE, ALM, PLM, and Microsoft Office, PDF, and some others. The idea, as I said, is not to replace any one of those tools, but on the contrary, is to make a power digital thread, or to construct a seamlessly build a digital thread when this thread goes from one tool to the other, as normally happens in complex systems engineering projects. And normally one tool is not making or solving all the needs of the engineers, and you need to maintain this thread across different tools. So this is the idea of this interoperability hub, to maintain the source of truth in the corresponding tools, but to synchronize all these source of truth into one unique digital thread maintained in our ontology, maintained in our repository. So this is the idea. And on top of that, and continuing with what has been our business for quite a long time, we have implemented a series of technical management processes on top of our own tools, of course, but also on top of all these other tools that we connect to. So if you remember us to be one of the main tools in the field of requirements quality checking and quality authoring, now the idea is that you can do exactly the same on top of any of the tools that I have included in this list. And of course, the rest are not included in the previous slide, but as I said, we connect to over 50 different tools. So the idea is that all this ecosystem is implemented, as I said, on top of our ontology. So this shape is representing our ontology. And today, what we have done is we have implemented a bunch of different artificial intelligence methods, classical, but also large language models and small language models, to make possible this that some people nowadays call neurosymbolic artificial intelligence. So this is what we have built, and this neurosymbolic artificial intelligence is capable of enhancing the number of features offered by other tools, especially for textual artifacts, but also for MBSE artifacts. And of course, requirements is a great candidate for this enhancement. So this is what we are going to see into this joint endeavor that we have signed, PTC and various company, technology partners nowadays for since a couple of years. And I can tell you that, of course, the level of integration with these different, more than 50 different tools, the level of integration could be not exactly the same, but in the case of PTC Codebeamer, we have reached 100% of this integration. So one of the best candidates to show how we can connect to the different tools in the market is, of course, to show it on top of Codebeamer. And this is what we will see today. So 4 different scenarios, some few words about these scenarios. The first one is, as I said, the connection of artificial intelligence techniques. So plenty of techniques like those that you can see on the right-hand side of the screen. Also, as I said, the implementation of large language models, small language models, on top of all the different tools that we can connect to. So the idea is to make possible that the input for the artificial intelligence methods could be the information maintained in this digital thread, regardless of in which of the tools you are managing this data and this information, to be processed with algorithms or artificial intelligence workflows that can be generated with one of our tools. This tool in our system, in our ecosystem of tools, is called DMS, Decision Management System. So the main scenario that one of the scenarios that I will present you today is to use this artificial intelligence for the extraction of content for the ontology. I mentioned the ontology. The ontology remains like one of the most important assets when it comes to do advanced systems engineering. and building ontologies is sometimes not an easy task, right? So that's why we have implemented one of our first methods is to help engineers implement or fill out, populate their ontologies in an assistant way, um, thanks to several different artificial intelligence algorithms. So the second topic, changing gear a little bit and coming back to our previous life, let's say, is requirements quality. Perhaps you know us for this and our CCC approach, correctness for the quality of individual requirements, while consistency and completeness for the to be applied to sets of requirements and models. Of course, all these capabilities are implemented on top of Codebeamer, including the possibility, of course, to check those rules in the INCOSE guide. But we have, as you know, we have plenty of other guides already implemented, like NASA or the rules in the NASA system guide, or the ESA rules to drafting requirements, and plenty of others. And in terms of the writing assistants, we have implemented also the notion of the requirements pattern. You can find in our website the libraries for the EARS, easy approach to requirements syntax, EARS patterns, and plenty of other patterns. This is, for instance, our tool connected to Codebeamer and representing how the quality of a given document is. Hopefully, according to this chart, is the quality is improving according to this chart. So this is the kind of things that you can do, including, as I said, the CCC approach, quick detection of duplicates, and plenty of other things, together with the notion of helping people in real time. So what you can see in this screenshot is Codebeamer, and on top of Codebeamer is our requirements assistant. Right, so the famous RAT, it is our assistant to write high quality requirements. Now we have extended the number of tools we can connect this writing assistant to, and one of the tools is, of course, Codebeamer. Even if Codebeamer is normally presented as inside of a web browser. So the idea is that we have developed a browser extension, so that the RAT, the writing assistant, the requirements writing assistant, is on top of tools like Codebeamer, helping real-time check the rules that you enable, and helping following the patterns that you select and fill out the slots of these patterns with the information coming from the ontology. I will show you this in detail in another video. So the third demo that I will present today is about interoperability and traceability and interoperability. So as I said, of course, if I want to trace two elements that are managed inside Codebeamer, the best solution perhaps is Codebeamer to establish this trace. However, normally you will find the need to extend this thread, this traceability, towards other tools outside of Codebeamer. It could be that you want to connect to, I don't know, as I will show in my demo, regulation in a PDF, or external requirements in Excel, or whatever. Or it could be that you want to trace to conceptual modeling tool, or physical modeling tool, or an external testing tool, whatever. So the idea is that whatever of the other tools that you can connect to our interoperability hub, you can establish traces between Codebeamer elements and these other external elements, even if the other elements are not part of Codebeamer. So this is the notion of extended traceability, but we have also provided more features to this integration with this possibility to exchange requirements between Codebeamer and any other requirements management system. So we have connectivity to other tools like I don't know, like Doors, classic Doors, Doors Next Generation, Polarion, and plenty of other tools. But also, as you know, in modern MBSE tools, normally they also allow for room for requirements as well. So you can, as I will show in one of my demos, you can take the requirements in Codebeamer, push or synchronize those requirements into an MBSE tool. Perhaps if you allow this in your process, make some changes within on top of the architecture. You can adapt a little bit your system requirements, or you can extend or derive more requirements from your architectural decisions. And then you can synchronize back all these changes. The delta of these changes can be synchronized back to Codebeamer in a very easy way, right? And of course, generation of transformation of these elements into other elements. So this is a screenshot represents this traceability project extending way beyond Codebeamer, connecting to, in this case, Capella, Word, Excel. In the video, you will see other connectivities. Also, and thanks to these artificial intelligence and semantic algorithms that I was mentioning before, we have offered the possibility to suggest traces between two documents. So, for instance, suppose that you write your requirements as a black box for your system of interest. So this is my system. And then I go to architecture, I decompose my system into a series of main level 1 systems. And then you write another specification for each one of these systems conforming your full system. The idea is that for each couple of these, for these couple of documents, you can create traces between the top document and each one of the sub documents, right? And you can ask our tools to suggest traces based on different algorithms. Our tools can suggest traces that can be synchronized back to the main tool, to Codebeamer in this case, right? So this will be presented. And something that, of course, I don't have time to present all the cases, but it is also important is, for instance, the possibility to start with a model and generate requirements for these models, or the other way around, start with requirements document and generate models for it. This is the only case that I will not present as a demo today, right? So I think, well, this was the architecture. I skip this; it's a little bit too technical. So I go directly to my demos. The first one is to extract, as I said, extract the key vocabulary from a document. So for this exercise, we have started with well, this is our DMS module, and this is our knowledge manager. So as you will see now in a moment, I go to see how many states and modes I have in my system. I had only 2 dummy elements. And now I connect the Engineering Studio 2 to a Codebeamer document. I retrieve all this content. These 153 elements are coming from Codebeamer. So you can see that the first step in this workflow is to recover the requirements, then select which attributes you want to deal with. Then the third is to provide the patterns that will help in the extraction. And the fourth is of course to discover the vocabulary, and the fifth step is just to store this vocabulary in the ontology. So once I have selected the Codebeamer, I go to the second step and I pick one pattern out of the list of patterns in my database. It's a pattern, of course, describing what could be a transition. So this is the last part of state transition pattern. So, okay, this is my single pattern. Of course, you can select many different patterns in the same step. Here, you can select more than one pattern, but this makes the result a little bit more complicated, right? Or more time-consuming, better said. So we only selected one pattern that has identified these 5 different content that were not in the vocabulary, and of course were not into the cluster state or mode. So what you see is, okay, the tool is telling you this is the pattern that has been recognized. This is the source requirement where we have recognized this pattern, and this is the vocabulary that the tool is suggesting you to first to put into the ontology, and second to put it under the cluster state and mode, right? So if you accept, of course, everything has to be validated by a human. So if you accept this and save, then all this content will go directly to the ontology so that it could be used in the next steps. So everything is here now, ready to be used in the next demos. So this was the first demo, vocabulary extraction. Second is our classical requirements quality, right? So in this second demo, I will fast forward a little bit. I connected to my Codebeamer project, right? So this is exactly the same content as what you can find in Codebeamer. And I will pick only one tracker, one document from this project, right? I configure the tracker by establishing mainly three things. So the first one is who can access this content from within SES. Of course, always after having provided the credentials, the Codebeamer credentials, right? So we don't skip the Codebeamer security. You always need to know your credentials to retrieve content even from within our engineering studio. Second one is out of all the attributes in this document, you can pick which ones you want to show on us, right? So you can pick 1, 2, 3, or as many attributes as you wish. And the third aspect that I will cover here is since I would like to write requirements following a set of agreed patterns, I will select in the connection, I will select which patterns I want to follow. I want my writers to follow, right? So I have selected the patterns defined by EAS, easy approach to requirement syntax. Well, with this, the connection is created, the connectivity is created. So I just give a logical name. So this is the logical name for this connectivity that you can share with your colleagues if you check on shared connection here, right? If not, this connection will be only to your local profile. So whenever you create this connection, you will have this box, and then every time you need to open, you don't have to provide all this information. You just double click. And unless you say that you want to remember credentials, the tool will ask you for credentials every time you double click on it, right? So now the tool is using the Codebeamer API to retrieve content from the Codebeamer repository and present this inside of our tool, right? So these are exactly the same requirements as what I presented in the web interface. So the next step, of course, you can see the different columns and so on. So the next step, I am fast forwarding a little bit more. The next step is to select which quality metrics I want to apply. In this case, I have different combinations of INCOS rules that has been implemented in the tool, and you can pick which ones you want to use. In this moment, I have selected this third belt, as we call it, implementing this 40-something INCOS rule. So from now on, if I go to the quality tab for this document, quality view, then I can now analyze the quality of my document according to these 40-something rules that has been selected. Of course, there should be different roles in this game. One role establishing the parameters, the quality rules, the patterns to follow, and so on and so forth, and another role to write the requirements. Normally, the requirements writing could be done, of course, can be done from here if you wish, but normally will be done from within the Codebeamer interface. So that's why once I assign my quality rules, I go back to the Codebeamer interface, and I pause for a second. This is the same document, but now in Codebeamer, right? Once I create a new requirement, I give the name of the requirement, then now it comes to write the actual text of the requirement, right? So I can, of course, I can follow the typical Codebeamer way, which is, okay, I just go and type whatever I want to type as the text of my requirement, or I can click in here, which is the requirements assistant to help you write real-time quality checking of the rules that the other guy has assigned in the other tool, and connect to the ontology to follow the patterns that has been assigned to this document. So this is what I'm going to do. So I click on this button to open the requirements assistant, the RAT assistant, right? So I click on it, and then RAT online appears. So this is a new implementation of RAT, and it is telling me in real time that, well, this requirement is empty. But even if it is empty, it is low quality. It is low quality because it is breaking three main rules. There is no shall, there is no main action. Of course, it is an empty requirement, so it cannot be a good requirement. So the tool allows you to do two main things. First is to write without the help of patterns. I have not selected any single pattern here, so I can type whatever I want to type. And in real time, the tool will analyze your requirement and will tell me what it finds. So it finds another three issues, now different issues. So the tool is telling me that should is not welcome in my document. The document was expecting shall. I'm using passive voice. I'm using an imprecise quantifier like vary, which is not welcome normally in requirements. So this is not a good requirement. It is poor quality for this requirement. So I remove all this content, and now I would like to use my requirement following one of the patterns that I am offered. So you can see the list of patterns. I pick one of them, like ubiquitous requirement. So this is one of the classical patterns for described in ES, in the easy approach to requirement syntax. But in this case, it is to a particular case of this ubiquitous. It is to write a physical property, a property to describe, a requirement to describe a property. So that's why as soon as I start typing, the tool goes to the pattern definition and checks that the first content is or shall be the name of a property. So that's why the tool goes to the ontology, retrieve all the properties from the ontology in front of me, and then now I can start typing, which is or just selecting with the mouse which is the property I want to involve in this requirement, the height of the. And now the next step should be the name of a component. So now, if when the tool goes to the ontology and retrieves the content from the ontology, I will see now name of different entities in my ontology, right? So I can now use the keyword to go up and down in this list, or I can start typing, and the tool will reduce. The list will be reduced only with those elements starting with what I'm typing. So I can pick, okay, I want to speak about a system which is called the temperature weather. So this is the name of our system. So next step in the pattern is suggested automatically by the tool, which is the shall be, and then whatever, shall be. So this is the notion of following patterns while writing requirements. I have finished, supposedly I have finished my requirement, and now the tool is telling you with this green match label here is telling you that you have matched the pattern that has been selected, which is pretty well. But it is telling me that there is a little bit of an issue according to the INCOSE rules, which is that it is lacking tolerance. The height to be exactly 25 centimeters is something difficult to verify. So it is better with tolerance, but of course it is not the key point for this webinar to show you how to get rid of this. If you want to learn more about this, we have plenty of other webinars speaking about this topic. So you just click on save, and remember, this is not this is not two different tools. It is the same tool, fully integrated. So as soon as you click on save, the content is on top of Codebeamer, so that you can provide the rest of the attributes or traceability or whatever, and you can now save into the Codebeamer repository. If now after saving I go back to the Engineering Studio, I can now refresh the content so that the tool knows that there is one new one new requirement. I move a little bit so that you can see that at the end of the list, you have one green item corresponding to my new requirement. Now I save again to take this new content into our ontology. So now the ontology and the source of truth, which is Codebeamer, are in fully synchronization, are fully synchronized. So I can go back now again to the quality view, so that I can proceed with with all the classical quality checking that you know pretty well, that can be done with our tool. All this quality checking in real time. Sorry, not in real time. Sorry, but now you can analyze not only correctness, but from this tool you can analyze correctness, consistency, completeness. You can generate quality reports. You can see how is the evolution of quality. So if you are interested actually in knowing more about what is this quality checking on top of this tool or on top of any of the other tools that we can connect to, I encourage you to contact me or to check any one of our old webinars where we present this and the quality results and the quality evolution, and all this information is presented in detail, right? So for the moment, I close this second scenario and I go to the third, which is traceability, extended traceability. So the idea now is to extend traceability beyond Codebeamer. As I said, now I will connect Codebeamer with another Codebeamer document to suggest traces, but also to Enterprise Architect with some architecture in it, and also a standard with some regulation in PDF format. So this is again the Engineering Studio. Now, together with the first document, I have created another connection to another document. These two documents are within the same project in Codebeamer, and of course, I can create traces inside of Codebeamer for these couple of documents. But what I'm going to do here is ask our tool by means of this semantic and artificial intelligence mechanism. I will ask our tool to suggest traces between these two documents. One document, the first on the left, is the full system, the main system, with 146 requirements. The document in the right is one of the subsystems, only with 20-something requirements. So what I'm going to do now is I will create a traceability module for these couple of documents, right? This is going to be created in our ontology. So every trace you put inside of this traceability module will be stored for the moment only in our ontology. So you give a name, you select which type of traces you want to create between these two documents. In this, for this particular case, I have selected allocate, derives, and flow down. Then you select the source and the target. Since I have only two documents open, then these are the only two possibilities that I'm given. And well, a little bit of the configuration for the semantic algorithms, the level of some thresholds, and the identification of which is the algorithm I want to use to retrieve similar requirements. So the traceability module is created. Double click, it is created, but it is empty. There are no traces yet between these two documents. Well, creating a trace between two documents is as simple as you go to the source and select one requirement in the source. You go to the target, select one requirement in the target, and you select the type of trace you want to create, allocate or derives or whatever. So once the source and the target are selected, and click on trace. So, well, there is now one trace created for this document. You can edit the trace, you can see the details, you can change the type of trace created among the three that I selected at the beginning. You can provide a rationale why these two requirements are to be connected or need to be connected, and so on and so forth, right? So as simple as that. But now what I'm going to show you is how artificial intelligence can help and provide me with traces. So the tool is suggesting me that these two requirements, remember always, when you see the details of a trace, always the element that you will see in the left, it corresponds to a requirement in this document. the element you see in the right corresponds to a requirement in this other document, right? So as you can see, this is just a classical flow down to represent regulation. I am obliged to follow this regulation in the full system, temperature warrior. So I will need to obey the very same regulation in all the subsystems, like the control system. So it is normal that the tool suggests this trace between these two requirements, where the only difference is that the subject of this requirement is the main system. The subject of this requirement is one of the child requirement in the PBS, right? So normally I will go and accept this suggestion. So thank you thanks to the Engineering Studio, I now have this new trace. And pretty much the same for the second, which is establishing some limits in temperature for the operation that apply to all the subsystems. So I have also accepted. Now I go to another mechanism, suggested mechanism, which is to help me identify properties, requirements speaking about properties, like the one that I have written before about the height. So the idea is that now the tool will try to find the potential couples of requirements in both documents that are to be connected. So an important point here is that, if I go back 1 second, an important point here is that it doesn't matter the structure of the requirement. So in the source document, the requirement first names the property, which is the power consumption, and then and then the system name, temperature warrior, shall be whatever. In the second, the structure of the requirement is different. So first, the requirement names the system name and then the property. So the grammar, the structure is different, but of course the formal representation of these two requirements is exactly the same. Well, with the only difference that this one is naming the main system again, and this one is naming the subsystem, right? But in my understanding, these two requirements are to be traced. So the suggestion offered by the tool is accepted by the engineer, and I can do the same with the other suggestions. So I take this one, which is speaking about the maximum weight of the temperature system, the temperature warrior, and the maximum weight of the control system. So I go and accept it, but I can see that the tool has detected duplicated requirements in the source document. So I accept one of the suggestions, but I will not accept the others. Indeed, I will go to this other document and to the source document and remove this duplicated information. It is not covered in the video, but this should be the natural step should be to remove this. And then the final, we have plenty of other algorithms to suggest traces, but now I just want to suggest traces only due to the fact that the main verb after the shall in two requirements could be the same. So now the tool is looking for all the potential pairs, potential candidates to be traced. And when the main verb after the shall is the same in the source and in the target, these will be the ones offered as potential candidates to be traced. So with a double click, you can check both suggested requirements to be traced. And if you agree, you just click on accept the suggestion. If you disagree, you just reject the suggestion. Of course, you can accept all or reject all in a single click. You can have all this working, which is what I'm going to do now. I'm going to right click, accept all the suggestions, and I have all of them in my repository. So let's change a little bit and close this traceability module, because now I want to show you how to trace to an external document. So for the moment, I have used the suggestion mechanism to suggest traces between two Codebeamer documents. But now I want to add a new connection. Now it is to a PDF. As I said, I wanted to involve regulation. So this is a fictitious standard that is regulating my system. So this is a PDF document. So our tool can parse the entire document, or you can select one particular section. I can try to identify the meaningful blocks with a label. So you can name the label will be something like reg for regulation plus a 3-digit code, consecutive number that it is maintained by the tool. Something like this. This is the example. And what is important is that you can apply different algorithms to determine which paragraphs are relevant or not. So the basic one is, well, this document includes shall statements. So you can say, okay, every paragraph with a shall is a valid, is a candidate for a configuration item. You can, if you know our ontology, you know about clusters, patterns. So you can use clusters and patterns to have a more accurate selection of configuration items, or even regular expressions. So paragraphs containing this or matching with a given regular expression should be relevant paragraphs and should be considered as configuration items. Then you can even do things like, adding attributes. So there's no formalization because I don't want to write new requirements to this standard. But I can say, okay, I want to create an attribute to describe. So I go very quick here, permissions, and an attribute to describe the level of risk or the level of complexity to address all these aspects, right? So once the connection is created, you just double click on it, and then you see that the tool has identified 28 work products, right? So you see all these in here. You can see the document. Of course, normally this tool is intended to be worked out with 2 physical screens normally. All these panels are dockable. You can dock in the screen, but you can also dock in a second physical screen. So if you have 2 screens, you can split and have, for instance, the view for the standard in one screen and the view for the requirements document in another screen, right? But as you can see, the tool has identified all the paragraphs with a shall as potential configuration items. So these items are in green, as you can see, not yet in the ontology. So now I click and save so that this content goes to the ontology. And of course, if I provide a value to this attribute that I have created, like the level of complexity or level of risk to accomplish each one of these blocks, then all this information shall not be stored in the PDF file itself. It will be stored in our ontology, right? So now if I connect to Codebeamer, then I can see side by side, I can see on the left my standard, and on the right I can see the document. Establishing traces is easy. First, I create in here a new traceability module. Perhaps the type of trace I would like to be something like regulates, which is not in this default ontology. Well, it is not a big problem. I can right click, and in a minute I can create a new type of trace with the name you wish, like regulates. And of course, you just say, okay, the source. How do you want to name the source? You can say that the source is the regulation, while the target of this trace will be your system requirements, whatever. So in less than 1 minute, you have a new type of potential trace. You pick this for your document, and you select, as in the previous case, you select that now the source is a PDF and the target is my system requirements document. And that's all. So the traceability module is generated. Now, of course, no traces in it, but double click and you can do whatever you wish. So you can trace by hand, you can trace based on a suggestion method, whatever. If you want just to trace by hand, you can use the search box on top of each one of these panels to find out the elements that you are interested in. You select one element on the left, you select one element on the right, you click on the trace button, and you have it. in less than 1 second. Of course, you have a trace between these two elements. Now you can get into the details, provide a rationale as we did before. This information can be exported in XML. You can import XML or sorry, Excel. So all these operations are potential operations that you can do whenever you wish. And similar to when it comes to define the architecture in an external MBSE tool, right? So I have connectivity also to an enterprise architectural element. So I create a new traceability module between my system requirements and the architecture in Enterprise Architect. So click OK. The new traceability module is created, and of course will be created and it will be empty, right? So establishing traces between requirements in Codebeamer and architectural elements in Enterprise Architect is as simple as you pick a requirement, you pick an element, and you click on trace. As simple as that, right? Again, you can provide your rationale, you can do whatever you wish. What is important here is that we have also implemented a mechanism to identify automatically traces between the elements. If I take a requirement saying that the temperature warrior shall have a mode called combat mode, then the tool is suggesting, okay, please trace this with the mode named combat mode in Enterprise Architect. So these are the kind of suggestions that are offered. Of course, now I have something like 300. I can review all of them, whatever. And for those that I accept, I just go and say accept all or reject all or whatever. And then I will end out with my 300 traces in the repository. As I said again, whenever you connect two documents that are not within the same source of truth, this is Codebeamer on the one side, but Enterprise Architect on the other side, all this information will be stored in our ontology. So now the 300 potential traces are accepted, and that's all, right? So this is for the moment, this is my traceability map, including 4 documents, including 3 main traceability modules, right? You can see graphically, you can see the map, you can, if you zoom in, you can see the content of each one of those traces, the sources, the targets of the traces, and so on and so forth, right? So this is part of the tool. But now I will show you how I got version 2 of my standard. I can save this version 2 to override the version that has been connected previously to the Engineering Studio. So now I am overwriting the version 2 now is the version that the tool will take. So I close PDF and I will open back the Engineering Studio. And within the Engineering Studio, I will ask, okay, I want to open you PDF, my standard. So important. Now the tool knows that there has been changes and is asking me, do you want to create a baseline before I override the changes? Okay, yes. So this is baseline version 1.0. So this is what went before the change. And now the current baseline will be the new content. This version 2 will be the current while the tool is storing the previous one. So this allows you plenty of different things like checking how many baselines in the document, even if it is PDF, checking how many baselines, compare one baseline with the previous baseline. But now what the tool is showing you in different colors is yellow for the modified, green for the new, and red for the removed, right? So the tool is showing me that this requirement or this piece of the regulation has been modified. If you want to see the previous content, you right-click and compare this version for this particular requirement with the previous version, whatever. Or you can go to trace, and before you accept, you can see what could be the impact of this change. So you move to traceability, and now in the right traceability view, but only for this particular selected requirement. So what you can see here is that this particular requirement only has one trace with one direct trace, but you can see the global impact If you click there, then you will see the global impact in a graphical way and see how many other elements are traced at different levels. Or you can continue with double clicking to expand the traces from the PDF regulation to a system requirement, from this system requirement to a subsystem requirement, and to block a component in enterprise architect, right? So this is the impact analysis that we offer. And now, quickly, the last use case is interoperability. So this video is a short one, but just to show you how we can connect to enterprise architect, not to retrieve architecture, but to retrieve a requirements package. So I have a package for requirements called TW, temperature war requirements. So I have two connectors now to enterprise architect, one for the architecture and another one for this package of requirements. So if I connect to the requirements package, I can see that it is empty. So there are only one empty diagram and one sub package, but there are no requirements. So there is no content in this enterprise architect requirements package. So my intention now, and yes, I am opening now enterprise architect to show you that it is empty in terms of requirements. This package is empty. So the intention now is to move, synchronize all the requirements in this Codebeamer document into enterprise architect just with a click of a button. So we have identified what we call in our tool interoperability algorithms. So I edit a little bit just to show that interoperability, first you have to name what is the source and the target document. Then there is a mapping where you identify which is the container into this into the source and which should be the container into the target. Then you have also the mapping, which elements are to be treated, only requirements. And then mapping also of attributes. So requirements on the left will be transformed into requirements on the right. But also I want to map some attributes like the attribute header in Codebeamer will be transformed into the attribute alias in Enterprise Architect, right? You can map as many attributes as you wish, and you just run interoperability. This is real time. In 1 second, you have everything on the right, but this is still in memory, not persisted into the Enterprise Architect model. Now, when you click on Save, now the tool is persistent in Enterprise Architect. So I can go to my Enterprise Architect in real time, and if I refresh the content, you will see with F5, then you will see like there are, not all of them are already there, but the first requirements are already there. So in something like 5 to 10 seconds, you will have all your requirements properly represented in Codebeamer. Now I think, okay, now saving the last versions, and all the requirements now are stored in Enterprise Architect, right? Of course, you can from here you can edit, you can trace, you can modify, whatever. So what I'm going to do is I have modified this requirement from 25 centimeters. Now it is 20 centimeters, and I will take the opportunity to create one more requirement. Let's say that deriving from my architectonic decisions, I want to create one more attribute. You can provide which is the type of the attribute. In this field, the name, you just give whatever ID, because the tool will take care of the ID. So this X will be replaced by the proper requirement number. And you just give the text, the temperature warrior shall, shall control the temperature of the opponent, whatever text for my requirement, and I will save in Enterprise Architect, and this is the alias, the short name, opponent temperature, whatever, right? So now the point is this new information has been created in Enterprise Architect, but not in the interoperability hub, not in the repository. So when I go back to the Engineering Studio and I refresh, what I will see quickly is that there are some changes. As happened with the PDF, the tool will show you the yellow element is the modification, the modified element from 25 to 20, and the green one is the new requirement. When I save in here, then now I am putting in sync again the repository with the source, with Enterprise Architect. Now by saving, now again, these two elements are in sync. But what is not in sync yet is the Codebeamer document. And now with this other reverse interoperability module, now in a couple of seconds, as you can see, now the Codebeamer module has the new requirement, this still without an official ID, as you can see, and you will have the modified requirement, 20 centimeters instead of 25. By saving there, then these changes will go also to the repository, and now everything is absolutely in sync. And by opening now Codebeamer itself, then you can see the new requirement, and you can see the modified requirement. Okay, the modified is there. Okay, with 20 centimeters now also in Codebeamer. So we have synchronized and a round trip of changes of requirements between these two tools. And that's all. Now it is your turn for questions and answers. I don't know if my colleague Cecilia is back with the mic properly working. Cecilia, are you there, or should I conduct the Q&A section? Cecilia, I cannot hear you. Cecilia? Well, it seems that for the moment Cecilia cannot reach me, so and I cannot see your questions. While you keep posting your questions, and I hope Cecilia can manage to send me your questions by Skype or whatever other mechanism. I just first introduce our next webinar that will be October 22nd and October 24th. Where we have, if you know the INCOSE guide for writing requirements, what we are doing is we are challenging NASA requirements documents with this INCOSE guide, right? So the idea is something like we will ask ourselves whether or not all these hundreds of requirements documents written yearly by NASA, if they apply first to the NASA rules first, and also to the INCOSE rules. So this will be our webinar in October. And I would like also to invite you to our next and first systems engineering conference for interoperability, right? Well, I think there's something missing here. So it is an interoperability conference. So it is not a systems engineering conference. It is a systems engineering interoperability conference. This conference will be held on the 13th and 14th of November in Madrid, Spain, where we will present tens of different use cases from industry. This is going to be mainly industrial conference with a lot of defense and aerospace, mainly companies and other sectors as well. If you are interested, you have more information in this link, or please scan the QR code to get more details. Well, it seems that there are, at least my colleague Cecilia has managed to post me a couple of questions. One is how is rich text of Codebeamer, like table images, handled in the user interface? The idea is that well, even if for the sake of simplicity, I have used plain text in all the process, but tables and formats and images are also treated. And when it comes to move information from one side to the other, all this information is moved accordingly, right? Second question is, what about tool performance while handling a huge number of requirements, like a few thousands or even more? Of course, when I said, wow, in 1 second you have all the requirements from one side to the other. Yes, the point is that I was moving or synchronizing 100 or 150 maximum in these videos. Maximum it was 150. When it comes to deal with thousands, of course, it cannot be done in terms of seconds. But the good point is that this is not an exponential process. If 100 takes 1 second, 1,000 takes normally 10 seconds, right? So this is the good point. Few thousands, it doesn't have to be a big issue. Is this connection bidirectional? Yes, by definition, whenever we connect to whatever tool, could be Codebeamer, but it could be Polarion, it could be DOORS, whatever, we always create the bidirectional connection to this tool. And we never create point-to-point connections. So you have seen here a connection from PDF to Codebeamer, connection from Codebeamer to Enterprise Architect. We never create this point-to-point connection. So the connection that we create, I think there is exactly here. So the connection that we create always is a bidirectional connection for each one of the tools. We have this bidirectional connection, and then whenever it comes to transform from one of these tools into another tool, then first it is translated into our canonical representation in the interoperability hub, then it goes through the hub, and then it goes up to the target tool, right? Never bidirectional, never point-to-point connections. So this enables, of course, according to your questions, this enables bidirectional operations. Cecilia, I think we are running out of time. We have overpassed indeed the expected time, but I don't know if you have any other question recorded. If not, I would like just to say thank you for your attention, and please stay tuned for other events and webinars. I hope to see you soon. And if you like any of these 4 scenarios that I presented, and you want to get more details, you want to get deeper and deeper on it, please don't hesitate to drop me an email or request a meeting with me so that we can discuss in detail. Thank you very much, and stay tuned for more about digital thread, requirements quality, and all these interesting topics. Thank you. Goodbye. Have a nice day.